Now, first thing we're going to talk about, right? We spoke about terminology in the first lesson. Well, you and teacher Jen, right? Spoke about terminology. So what is a monomial? Who remembers what a monomial is in an algebraic expression? A monomial. We had a monomial and then we had a binomial, and I can't spell. Do any of you remember what these are? One what, Linomta? A monomial is one what? An expression that has one term. And what about a binomial? A binomial, like a bicycle, has two terms. Okay. There we go. So now we're going to look at what happens, or how do we multiply a monomial. As we can see here, one term, it's just a 3, with a binomial, which is x plus 5. So those are two terms, okay? So we're going to look at the two methods that they give us here. The first one is the claw method, otherwise called what? What do we call this method? It starts with a D. There's another word for this method. Here they call it a claw method, but we have another word for it that we usually use, and it starts with D. Nice, wait, it's distribution. Okay, so the claw method is just the same as distribution. Right, and then the second method that they have here is the box method. So what they're saying is, the first thing you are multiplying, you put it on the side. And then the second thing, you put it at the top. This is just to make sure that you multiply everyone with everyone. You don't leave any terms out. So when you look at the claw method, you're obviously going to distribute it. So you're going to say x times 3, and then 5 times 3. That's just distribution. With the box method, you write it inside the box. So you say x times 3, and you write it inside the box where they intersect. So 3 and x intersect over here, and the answer is 3x. And 5 with 3 intersect on this box over here, and my answer is 15. So we're going to do a bit of all methods today. So let's get going. We have expand the following expressions, okay? So, okay, let me fix the way I'm sitting now. Hopefully you guys remember to bring a pen and paper so that you can do this with me. All right, so let's see. We're going to start with the first one, and we're going to distribute for our first one. So I'm going to take 3b, which is my monomial, which is outside. I'm going to take the 3b. Oh, I forgot to hotspot myself. Let me do that maybe. I mean, spotlight. Of course, I'm going to say hotspot. Okay, 3b, and you're going to first times it with 9x, and then you're going to times it with negative 2x. And I've emphasized that negative for a reason. Equals, okay. So the first one is going to be, what's 3b times 9x? Let's start with symbols. They're both positive, so then my answer will be what? If they're both positive and I'm multiplying, that means my answer will be positive. Thank you, Logan. Then let's go on to numbers. 9 times 3. What is 9 times 3? 9 times 3 is, nice, 27. And b times x is just bx. Okay, then we move on to the second term. This time we have a positive multiplied by a negative. So what is my sign going to be over here for this case? It is minus 3 times 2 is minus 6 bx squared. Can we do anything further with this? Is there anything else we can do here? We have a 27bx and a minus 6bx squared. No, because they're not like terms because of the square. Do you see the first x does not have a square? Yet my second one has a square, which means they are not like terms. They may have the same variables, but they do not have the same exponents. All right, let's move on. Here's the next one. Again, we have a monomial or one term, which is outside, and we are multiplying it with a binomial or two terms because they are 1, 2. So once again, distributive times S times -7R. Okay, let's start with symbols again. Positive and a positive. We said two positives give us a positive. And if there's nothing in front of my variable, then what number is there? If there's no number in front of my variable, it's a 1. So it's 3 times 1, which is 3 times 1 is 3. Okay, and then you just put down your variables, st squared. If you said t squared s, that's not wrong, but remember, we put these in alphabetical order usually. Okay, so I will put my s first and then the t after. And now moving on to the next term, I have a positive multiplied by a negative, so my answer is going to be negative. So it's -7 times 3. Nice, Bongo Musa. That will be 21 RT squared. Simple enough, hey? Simple enough. Okay, let's move on to the next one. I was just giving people who are writing down a chance. Let's move on to the next one. Now, we have a little bit more complicated here, but if you look carefully, it's still two terms inside the bracket, right? 5xy squared z cubed is one term, and 7x squared yz squared is the second term. And still multiplying it with one term, which is on the outside. So once again, we distribute, which means every term inside the bracket gets multiplied by the one that is outside. Once again, two positives, so we know it's a positive. And then 3 times 5. What is my number? It's 15. Now, let's look at our x's. I have an x outside my bracket there and an x inside the bracket. When we distribute, what are we doing? Which operation are we using to distribute? Which operation do we do when we're distributing? We are multiplying, right? And according to the laws of exponents, when you multiply, what are we supposed to do with the exponents of x in this case? Because we have an x here and an x there, we add them. So then it will be x to the power of what? If I'm multiplying x cubed with just an x, then it will be x to the power of 4. Nice. And then y and z, you just write them as they are. If anyone is confused, if there is no exponent there, there is a 1. Let me zoom out. Maybe we can't see. If there is no exponent there, it's just a 1. Okay, and then once again, we have a negative because I'm multiplying a positive and a negative. What is 7 times 3? Nice, Logan, 21. Once again, we have an x inside and outside the bracket. X to the power of what? Nice, Logan, 5. 5, because we take the x cubed over there and we add this 2 over here, and it gives us a exponent of 5. And then my y and my z squared just rewritten as they are. Now, before we go on to the next one, do we understand how to multiply a monomial with a binomial? Give me a thumbs up or a thumbs down. Thumbs up if you understand, and thumbs down if you're not quite sure. Okay. I only have 2 thumbs up and 100. Okay. All right. Okay. Thank you. Much better, ne? Now, let's see what's happening here. Now, we have two separate brackets. So my 3, I will multiply by 8x minus 4. But I also have a 4 that I have to multiply by 2x plus 5. So we're going to do these separately, which means do not get confused here. This 3 will only be distributed to the first bracket, and my 4 will only be distributed to the second bracket. So let us do so now. Let's start with the first bracket, okay? What are my two terms after I multiply out the first bracket? First, we have a 3 times 8x. How much is 3 times 8x? What will my answer be for 3 times 8x? Anyone? 24? Is it just 24? 24x. Nice, guys. I like the teamwork. 24x. And then we say 3 times negative 4. What's 3 times negative 4? Nice. Negative 12. Okay. Then I have a positive 4 times 2x. Positive 4 times 2x. That will give us 8. So plus 8. And a 8x. Oh, I almost missed the x there. And a positive 4 times a positive 5. What is that going to give us? A positive 20. Are we done with this question? Do you guys think we're done with this question? No, why not? Why not, guys? I see you all saying no, we're not done yet. Because there are like terms. Okay, identify the like terms for me. Which one is like terms with 24x? I have a 24x, a positive 24x. And the like term will be what? Which one is the like term? 8x, thank you. And then I also have another pair of like terms with my negative 12 and my positive 20. Do you guys see that? They're numbers, so they have like terms. They are like terms. Now let's start with the x's. Okay, 24x plus 8x. How much is 24x plus 8x? Nice. Equals 32x, not just 32, right? And then a negative 12 plus 20. A negative 12 plus 20 will give me, it's like saying 12 minus 20. Nice. That's positive 8. And now we are done. Okay. So that was all to do with multiplying a monomial or one term with a binomial, which is 2 terms. All right, now, how do we multiply 2 binomials? You guys know one of the rules. Which law do you know? How do you multiply 2 terms with 2 terms? I know there's that one rule that everybody knows when it comes to multiplying 2 terms with 2 terms. It's an acronym. Does anybody know what I'm talking about? Nope. Okay, let me just show you what I'm talking about. Okay, so in this case, we have 3 methods, okay? What they call the smiley face, but the smiley face is very similar to this acronym, which is what I was talking about. The FOIL. So you multiply the first, so the ones that are first in both brackets. So that would be your x and your x, okay? Those are the first. Let me actually highlight the arrows correctly. So it's this arrow. Those are the firsts. And then The outest, so the ones that are on the outside of the brackets, as in your x and your 3x. I mean your 3, excuse me, your 3. And then we have I for the ones that are inside or the inners of the brackets. That would be your 2 and your x. And then we have the L, which are the lasts in both brackets. So that is your 2 and your 3. So this is the FOIL method. Okay. Once again, you can use the table if you prefer it, the grid method or the table. It works very well as well, because if you look carefully, wherever these grids cross is the answer. Okay, so you take your two brackets, x plus 5, you write at the top. So I wrote there my x. I don't know why I'm trying to write x like them. I have here my x and a plus 5. Okay, and on the side, I have my x and my plus 7. In your first block, which two intersect? It is my x and my x. So then you find the product. X times x will give you x squared. That's the first one, right? And the second one, you look where x and 5 intersect, which is in this block over here. And that'll give you 5 times x, which is just 5x. Same thing with this x, this one with a 7. And finally, you take your 7 multiplied by the 5, and this gives you my 35 over here. Okay, so either one of these methods, should I zoom out for you to take a nice screenshot of all the methods? You choose the one that you are comfortable with. Okay, you choose the one that you are comfortable with. So there you go. Hopefully we've all taken screenshots of what we want. Now, we are going to simplify the first two using the block method. Okay, now luckily they filled out our brackets for us. My first bracket, well, my second bracket is x plus 5, which is this one over here. And my first bracket, x plus 4, is this one on the side here. So firstly, in the first block, that is where x and x intercept. So what is x times x? What is x times x? Nice, Logan. That is x squared. Okay, now let's go to the top right. That is where 5 and x intersect. So what is 5 times x? That is 5x indeed. Okay, then we move on to the bottom left. What is x? This x, the green x, times 4. That is 4x. And my final block at the bottom right is 5 times 4, which will give me 20. So once you do this with the block method, you are not done yet, right? There's a lot you can still simplify here. So you can now rewrite this as one expression. So you're going to write everything that's in the block. So that's x squared plus 5x plus 4x plus 20. Are we done over here? Are we done? No, because we have like terms. If you look carefully here, 5x and 4x are like terms. So I'm going to rewrite the ones that are not like terms. So that's x squared and then plus 20 over here. Let's look at my like terms. Positive 5x plus 4x. So that is nice. Positive 9x. Okay. Let's do another one with the block method before we move on to the foil and the claw and the smiley face and all of that. Once again, they filled in this block for us. Okay. X plus 9 and x minus 6. So all of the numbers in your block must go with their sign. If you look carefully here, my 6 had a negative, which is why the 6 is negative. Okay, so you acquire the sign that you had in the brackets in the first place. So let's start with my first block. Once again, we have x times x, which gives us x squared, x times 9, positive 9. That gives us x times positive 9. That gives us 9x. Okay. Now at the bottom left. Okay, now we have x times negative 6. So what is x times negative 6 going to give us? X times negative 6, negative 6x. And in the last block, we have a negative 6 times a positive 9. Negative 6 times a positive 9. We're multiplying a negative and a positive here. So firstly, we know it's going to be negative. Nice or funny. That is negative 54. Now let's rewrite them. X squared plus 9x minus 6x minus 54. Okay, equals like terms. Positive 9x minus 6x. X squared, you can't do anything with. It's on its own. But what is 9x minus 6x? Check carefully. Positive 9x minus 6x. Nice, Logan. It's positive 3x minus 54. Okay, before I move on, are we good with multiplying binomial by binomial? Let's have a thumbs up, thumbs down on that. Wonderful. I only have 2 responses here, guys. I need way more than that. Okay, there we go. That's much better. Okay, so the next one I want to try without using the block method. Okay, I want us to try the next one without using the block method, which means we're going to use the FOIL method. Okay, so the FOIL method is much more convenient because who wants to be drawing blocks in a test? You don't have time for that. In this case, they gave us blocks so we could just fill them in. But if they don't give you blocks, you don't have time to be taking out your ruler and drawing little blockies and making sure that's a lot, right? So let's practice using the FOIL method. So what does the F in FOIL stand for again? Who remembers what the F in FOIL stands for? First. So F is for first. First. That means the first one in both brackets. That means a squared as well as a. So what's a times a squared? A times a squared. Nice looking. That is a to the power of 3, or a cubed. Let's move on to the O in FOIL. The O, what does the O stand for? The outer terms. So outer. Okay. So my outer terms will be the ones on the very outside of the brackets, right? So it will be a squared multiplied by negative 7y. So firstly, we have a positive and a negative. So my answer is, if I multiply a positive with a negative, then my answer is going to be what? A negative 7 times 1, because there's nothing there, so it's a 1. 7 times 1 will just give me a 7, then a squared y. Then remind me, what does the I stand for? The inner terms. or just inner, okay? And my inner terms are negative 3y and a. So once again, positive and a negative. Positive and a negative. That is negative. And what's 3y times a? 3y times a. 3y times a is just 3ay. Okay, and then of course my L stands for last. Okay, so that would be my negative 3y and my negative 7y. So let's check here. A negative and a negative will give me what type of answer? I see Logan is already way ahead of me. Thank you, Logan. This will give me a positive answer. And then, of course, 7 times 3, that is 21. And y times y is y squared. Are we done with this question? Look carefully. Do you think we're done with this question, guys? Do we have any like terms here? Exactly, Logan. There are no like terms. So yes, indeed, we are done with this one. Okay, so it's not all of them that we will be able to simplify, but you must always check whether you can simplify or not. Okay, always check. All right, let's go to the next one. Then I have a little bit of a challenge for us before we do division. Let's do the next one. Once again, first, we say it is the first term. So that would be x and x squared. What's x times x squared? X cubed, that's true. So I have x cubed. Outer, so x squared times positive 9. X squared times positive 9. That is plus 9x squared. Okay, moving on to inner, which means negative 6 times x. Negative 6 times x. That is minus 6x. And we have our last, which is negative 6 times positive 9, which is indeed negative 54. Do we have any like terms here? Remember to always check any like terms. No like terms. So we are done. Okay. Now I want us to look at this over here. This time we have a, what do we call it when there's 3 terms? Before I tell you, what do we call it when we have 3 terms? We said one is a monomial. Nice, nice, Amy. This time we have a trinomial because we have a 1, 2, 3 terms multiplied by a binomial. Oh, okay. So I want to show you that even though the block method is tedious sometimes, it is very useful for days like this. Okay, because 1, 2, 3. Okay, let me disable annotation so that we can't all just scribble on the screen. Here we go. Okay, so on this side, I'm going to fill in. No, I need one more line. I need one more line. There we go. Okay, so on this side, I'm going to fill in my binomial. So I'm going to fill in my 3x with my minus 2. Obviously, if you're doing this in a test, you will close your table and draw a proper table. Okay, but for now, this is just a tool to help us calculate. And then at the top, I'm going to have to fill in my trinomial. And I just realized I don't have a big enough table, but I'll make it happen because teachers must make it happen. Maths people, make it happen. Okay. There we go. And I insert my last line. There we go. That's better. Okay. So my first term for my bracket is 9x squared. And then I have a positive 6x and I have a positive 4. Now, this is why this method is so useful. We're just going to fill in the blocks here where everything crosses. Okay, so for this first block over here, okay, the 9x squared intersects with the 3x. So then we multiply 9x squared and 3x. What is 9 times 3? 9 times 3, that is 27, and x squared times x squared times x, so it's 27x cubed. Okay, that was my first answer. And you can either go across or down, it won't affect your answer. Okay, just make sure you fill in all these blocks. So let's go across. In second block, we're here now. The ones that intersect are 3x and positive 6x. 3x times 6x. 3x times 6x. Firstly, is it a positive or a negative answer? Okay, there we go. Iminati has answered us. So it's a positive answer. 6 times 3 is 18. And x times x is x squared. Then we go to my last block over here. I have a 3x times positive 4. What is 3x times positive 4? That is 12x. Okay. Now moving on to the bottom row, okay? The first one, that is where 9x squared intersects with negative 2. Positive and a negative is going to give us a positive and a negative. That is a negative. 9 times 2. 9 times 2. Negative 18x squared, because x squared is just on its own, right? Next one, again, we have a positive and a negative, which is a negative. 6 times 2, or rather 6x times 2. What is 6x times 2? Oh, Fanny already gave me the answer. 12x. And my last one is negative 2 times a positive 4. And negative 2 times a positive 4. That is a negative 8. Okay, now we have all our terms. Let's write them nicely as an expression, okay? So it's 27x cubed plus 18x squared plus 12x minus 18x squared minus 12x minus 8. Right. Now, do we have like terms here? Do we have like terms? Yes, okay, we do. Let me get my colors. Give me some like terms. Does 27 have any like terms? Does 27 have any like terms? 27x cubed, excuse me, no. Okay, moving on. 18x squared. Do we have any like terms with 18x squared? Yes, okay, let me highlight it. What is the like term for 18x squared? Which one? Nice. Negative 18x squared. Okay, let's move on. 12x. Do we have a like term for 12x? Yes. Okay, let me highlight it. So which one is my like term for 12x? negative 12x, and then negative 8 is on its own. Now let's see. I'm going to rewrite my 27x cubed. Now, what is 18x squared minus 18x squared? 18x squared minus 18x squared. That's equal to... It's like saying 18 minus 18. They are like terms. They're the same thing, right? So it's 0. So it's gone. Is it necessary that I write the 0? No, it isn't. So all I know is that my x squares are gone. They canceled each other out, right? Moving on to x. 12x minus 12x. 12x minus 12x. That's also 0. And it's also not necessary for me to write it. So I'm just going to indicate here that they've canceled each other out. So which one is left? It's just the minus 8. So all of that work just to be left with 2 terms. Okay, guys. Hopefully you enjoyed that sum as much as I did, because we're going to start a new... Before we do, thumbs up, thumbs down. Did you guys enjoy and understand? Mostly, did you understand that sum? Did we understand that sum? Nice, nice, guys. I see celebrations. I see unicorns. It's making me happy. So happy. All right. Now, let's talk about division by a monomial. Okay? Division. So, no matter how many terms you have in the numerator, remember the numerator is the guy at the top, right? So, no matter how many terms you have in the numerator, you need to divide it up, okay? What that means is you need to put each term in the numerator over the denominator. Okay, I don't have space to highlight here. Divided by the denominator. Okay, so if you look carefully here, I had a 9x cubed plus 3x squared minus x. So I divided each of these into their individual fractions. So I put the first one, 9x cubed, and I put it over my denominator, which was 3x. And then I took the next one, which is 3x squared, and I put it over the 3x. And then I also took the last one, x, and put it over 3x. Now, the one thing you need to take note of is they kept their signs. Let me erase here to show you. What I mean is, this was a plus 3x squared, so you add. But this was a minus x, so then it's minus. Why would we divide it up, guys? Does anybody know why would we divide the sum up like this? There's a reason we are dividing it up. Am I allowed to divide or cancel out when I have pluses and minuses at the top? Am I allowed to do that? Can I just cancel out when everything is in one sum? Let me show you why you can't. Plus 3x squared minus x, and this was all divided by 3x. Okay, so if, let's say you decide you're going to cancel out the way it is, right? So you're going to say 3 goes into itself once and into there 3 times. Excuse me, and then you're going to do the whole exponents thing. So it's going to be 3 minus 1. So what's going to happen with these other two here? You have now used up that denominator and you cannot cancel it out again. Do you see that it doesn't make sense? So the first step, you have to break this up. Okay. The only time you can keep it together is if you have like terms in my numerator. And what would you do in that case? If we had like terms in the numerator, like if I had 2x minus x plus 5x over x. What would I do in this case? I have the same term, well, like terms, excuse me, not the same. I have like terms in my numerator. So what do we do when we have like terms? Anybody? What do we usually do when we have like terms? Like so. What would you do normally if you had a like term? You add them. Okay, so you would just add them. You would say 2x minus x plus 5x, which would give you 6x over x. And then these x's would cancel out and you'd be left with 6. But in this case, do we have like terms? I have a 9x cubed plus 3x squared minus x. Are those like terms? No, so you can't add them. So you have no choice but to put each of them under the denominator or over the denominator. Let's do an example. You guys are awfully quiet, so I feel like you might be confused, but let's see. So can you add the x to the like terms? What do you mean? Like over here. The only thing I can do is divide it at the end, but I first have to add those like terms, okay? I can't go any further without first adding these like terms. But if you're in this case, let's check here, 12x squared y minus 6xy squared. Are those two terms in my numerator like terms? Are these two like terms? These ones. Look carefully. I have a 12, x to the power of 2 and y, and xy to the power of 2. No, so I can't add them, right? I already know I can add them. So if I can't add them, what must I do? What do we do if we cannot add them? I split them up, right? So I'm going to say 12x squared y over my denominator, which is 3xy. Now, which operation is going to go in the middle here? Which operation is going to go in the middle here? Am I going to say plus or minus 6xy squared? Minus, nice, minus 6xy squared over 3xy. Is this not a bit easier to manage? This is easier to manage, right? So I have positive and a positive, so they're both positives. What's 12 divided by 3? 12 divided by 3, 4. And then I have an x. Now we are dividing. So everyone who was here when we did exponents, what do we do with exponents when we are dividing? What do we do with my exponents when we are dividing? We minus. Nice, Logan. So it's going to be x to the power of 2 minus 1 and y to the power of 1 minus 1. Minus. Okay, 6 divided by 3. What's 6 divided by 3? That is 2. And once again, we minus x to the power of 1 minus 1 and y to the power of 2 minus 1. If you guys are confused, these ones that I'm writing here come from the fact that there is no exponent. So if there's no exponent, my exponent is a 1. Now let's simplify this once and for all. This is equals 4x to the power of what? What's 2 minus 1? It's just 1. Is it necessary to write it? No. And then y to the power of 1 minus 1. Excuse me. Y to the power of 1 minus 1. That is 0. But anything to the power of 0 is? No. Anything to the power of 0 is what? So this whole y will become What's the law of exponents, guys? It's 1. Okay. Minus 2, and again, x to the power of 1 minus 1. What's 1 minus 1? It's x to the power of 0 again, which means it becomes a 1. And y to the power of 2 minus 1, which is just 1. Now let's multiply this, simplify it. It'll be 4x times 1, which is just 4x, minus 2y times 1, which is 2y. Okay, guys. And then we can do one last one before we leave. First step, divide them. So negative 10 x to the power of 4 over 2x plus 2x cubed y over 2x minus 6x squared over 2x. Okay, let's check. First one, I am dividing a negative and a positive. So then my answer is going to be what? A negative and a positive will give me what type of answer? A negative. And then 10 divided by 2. 10 divided by 2 will give me negative 5. And then once again, I have x to the power of 4 minus 1. Because if there's nothing there, there is a 1. Plus, what's 2 divided by 2? 2 divided by 2. That is just 1. Is it necessary that I write my 1? No. So I'm going to go ahead and write my variable. So it's x to the power of 3 minus 1, and y is on its own in this case. Okay, minus 6 divided by 2. That is 3, and x to the power of 2 minus 1. Okay, let's simplify. This is minus 5 to the times x to the power of 3 plus x squared y minus 3x. Is there anything else we can do with the sum? Is there anything else we can do with the sum? Without factorizing? No, there is not. So we are indeed finito with the sum. Okay, can I get a thumbs up or a thumbs down on dividing by a monomial? Dividing by one term. Okay, wonderful. I don't see any questions. We still have 8 minutes. I'm tempted to do this one. Let us do this one very quickly. We can finish. We can finish. Okay. 2x to the power of 5 over 2x plus 6x to the power of 4 over 2x minus 8x cubed to the power, oh, I'm done, over 2x minus 2x squared over 2x plus 4x over 2x. Okay, start with the first one. 2 divided by 2. 2 divided by 2. That is a 1. It's not necessary for us to write it. So it's going to be x to the power of 5 minus 1 plus 6 divided by 2 is 6 divided by 2 is going to give us a 3 times x to the power of 4 minus 1 minus 8 divided by 2 is 8 divided by 2, it's going to give me a 4. X to the power of 3 minus 1. Minus 2 divided by 2 again, which is a 1. That's x to the power of 2 minus 1. Plus 4 divided by 2. That is 2. And x to the power of 1 minus 1. Okay, let's simplify. X to the power of 4. This is plus 3x cubed minus 4x squared minus x, and my last one is plus 2. Why did I just write plus 2? What happened to that x? What happened to the x? Thank you. It became a 1 because it was to the power of 0. Okay, guys, I'll see you guys on Thursday.